Figure 2 shows part of a sketch of the curve with the equation y equals f of x. F of x is 8 sine half x minus 3x plus 9, and x is measured in radians. Note the definition is only for x greater than 0. We can see that on the diagram. The point P shown in figure 2 is a local maximum point of the curve. Using calculus in the sketch in figure 2, find the x-coordinate of P, giving your answer to 3 significant figures. So let's start with f of x being 8 sine half x minus 3x plus 9. So we want to differentiate that. We know that sine is going to go to cos. We also know that we need to use the chain rule, and the inside function is a half x, so we're going to get a half out of there that we need to multiply by. So we're going to get 4 cos, and of course the argument will not change. Never changes when you differentiate trig. Then out here we're going to get negative 3, and the 9 would disappear. We're interested in f dash x being equal to 0. In other words, that means that 4 cos half x, take away 3 equals 0, which gives me cos half x is equal to 3/4. And we can solve for that on our calculator. You can do that algebraically or graphically in all likelihood. So what are our first values? Making sure we're in radian mode. We have 1.45, 11.1, and 14.0. Now 1.45 is going to be this first maximum up here. The 11.1 is going to be the minimum value there. And so P is going to be the third one. So we can say x is equal to 14.0. And that's to the 3 significant figures required. Now we're told that the curve crosses the x-axis at A, which we can see just here. Given that to 3 decimal places, f of 4 is 4.274 and f of 5 is negative 1.212, explain why A must lie in the interval 4 to 5. The most important thing I think to state here is that the curve is continuous. In other words, you can draw it without taking your pen from the page. Saying that f of 4 is 4.274 is telling you that the curve is above the axis at 4. Saying that f of 5 is negative 1.212 is telling you at 5 the curve is below the axis. And if it's above here and below over here, it has to cross somewhere in between. And all of that needs to be written down. Part C, taking x0 equal to 5 as a first approximation to A, apply the Newton-Raphson method once to f of x to obtain a second approximation to A. So, Newton-Raphson formula is xn plus 1 is equal to xn, take away f of xn divided by f dashed of xn. So x1 is going to be x0, which we're told to take as 5. Take away, now let's think about what the function was. 8 sine half x, so that's going to be 2.5, half of 5. Take away 3 times 5, add 9, divided by 4 cos, remember half x again, so that's going to be 2.5 in there, take away 3, and then we just need to calculate that, and it is 4.80 to 3 significant figures.